So in this little part of the lesson, we're going to talk about angle of elevation and angle of depression. So the way I always think about this is that the angle of elevation is the angle that is going up. And this isn't going to write very well because I'm in PowerPoint. So the angle by which an observer's line of sight must be elevated from the horizontal to the point observed. You get in an elevator, you have the bottom floor, you hit a button, and you go up. That's how I think about this. And then the angle of depression, when you're depressed, you're sad or you are down. So it's the angle that's coming down. It's the angle by which an observer's line of sight must be depressed from the horizontal to the point observed. You have to be careful though, because it's from the horizontal down. It is not that angle right there. So it's not the angle inside the triangle, it's the angle outside the triangle. And if you remember from geometry, you actually have some alternate interior angles here, which we know are congruent, which means the angle of depression is actually congruent or equal to the angle of elevation. If you didn't get your definitions written down, go ahead and pause and write them down. And we're going to go through some problems. So let's talk about a parasailer. So a parasailer is attached to a boat with a rope 300 feet long. Okay, so we need a parasailer and a boat. So here's my boat. Okay, and some water, and then we need a parasailer up there. Let's see. So a parasailer, and there's his parasail. Okay, and he's attached to a boat. Okay. Hopefully, actually, I did not draw that correctly. I'm going to make him attached to the boat near the water so we get a decent triangle. Lost his arm. All right, and then you'll notice that we get this height in there, and hopefully you're seeing the right triangle there. So that's the goal of the word problems, is you got to find the right triangle. So the rope is 300 feet long, and the angle of elevation, so the angle up from the water to the boat, is 48 degrees. We are supposed to find the height of the parasailer above the boat, so we're looking at that value right there. So if I look at my SOHCAHTOA, or back in SOHCAHTOA world, I know that if this is my reference angle, this is opposite. And since this is across from the right angle, this is the hypotenuse. So I know that that is the SO part of SOHCAHTOA. So I've got sine equals opposite over hypotenuse. So I know that the sine of 48 equals x over 300. And I'm going to multiply both sides by 300. And I'm going to go back to my Desmos calculator. So I had 48 times the sine. That wasn't right. It was 300 times the sine of 48. So 222.943. 222.943. And we would label it with feet since the problem was in feet. Okay, now let's look. We've got from a point on the ground 28 feet from the base of a flagpole. So here's my point. Here's my flagpole. We know that that is 28 feet. The angle of elevation to the top of the flagpole is 63 degrees. Estimate the height of the flagpole, so we're looking for this. This time it looks like I have the opposite and the adjacent, and the opposite and adjacent is TOA, or tangent. So I'm going to do the tangent of 63 equals x over 28. I'm going to multiply both sides by 28. All right, and then I'm going to put that into Desmos. So 28 times tangent of 63. 28 times tangent of 63. And I get that it is 54.953. So 54.953. And again, we are measuring in feet. All right, we're gonna do two more quick ones here. So a boat is in the water. So we've got another boat in water. So I need some water. And I need a boat. You know what my awesome boats look like here now. The water level is 20 yards below a cliff. So now we need a cliff. So here's my cliff. Okay. The water is 20 yards below the cliff. The angle of depression. Okay, so this is a little bit different. Remember, angle of depression is angle down from a parallel or a horizontal. So that angle of depression is 37 degrees. How far is the boat from the cliff? So they want us to figure this out. I need the angle in here, but remember, these are alternate interior, so this is also 37 degrees. I have the opposite and the adjacent, so again, I've got TOA. So my tangent of 37 equals 20 opposite over x adjacent. And again, I have that variable in the denominator, so I have to do a little bit more work. I'm going to multiply both sides by x, and then I'm going to divide by the tangent of 37 because that's just an ugly decimal point number. And we're going to go ahead and go back to Desmos. 20 divided by tangent of 37. So 20 divided by tangent of 37, 26.540 or 541 if you're rounding. And I totally lost it now. 26.540, 26.540. And this would be measured in yards. All right. You are measuring the height of your school building. You stand 25 feet from the base of the school. The angle of elevation from a point on the ground to the top of the school is 62 degrees. Okay, so we've got our school building, which we better make in green since we're the Titans. So you've got the school building. Okay. You stand 25 feet from the base of the school. So here's 25. Oh, I'm way taller. Too tall. All right, but we know that that's 25 feet. Okay. The angle of elevation from a point on the ground to the top of the school is 62 degrees. Estimate the height of the school to the nearest foot. So we're going to do this right here. So I know I've got the opposite and the adjacent. And we've done a lot of tangents. It's a lot of TOA today, but it could be any of the 6. Typically, we mostly use sine, cosine, and tangent on these. All right, so I know I've got the tangent of 62 equals the opposite x over the adjacent 25. I'm going to multiply by 25. And we're going to go ahead and put that into Desmos. So I've got 25 times the tangent of 62. So I get 47.018. So 47.018, and this was in feet, equals x.